Good morning. So here I'm going to go through a practice test one that I printed off. I hope y'all can see my screen. Re-recording. Okay. So the first problem here is determine the measure of the acute angle theta for which cotangent of theta is 1 over root 3. Okay, so this is number one. Cotangent of theta is 1 over root 3. Okay, so you remember SOHCAHTOA. And the reciprocals, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So these are the reciprocals. So that means that if tangent is opposite over adjacent, then that means the cotangent is adjacent over opposite. So adjacent over opposite. Well, I think I know that triangle. Right? If theta is here and the adjacent is 1 and the opposite is root 3, I recognize that triangle. That would be the 1 root 3, 2, right? So that would be theta is pi over 3. You know, and generally, I like to write my triangles out so that I can refer to them while I'm working. Pi over 3 looks like this. That's usually how I start. And then that means this is 1 and this is 2. And then this up here is pi over 6. But I like to draw that separately like this. Pi over 6. Opposite that is a 1. This is root 3 and that's 2. And then we also have pi over 4. Pi over 4, that is 1, 1, root 2. So usually I like to have these written out and I just refer to them as I'm working, so that when I see this and I'm drawing that, then I can just tell you which one it is. You know, opposite is this and then adjacent is this. So and the reciprocal is that. So that's how I like to work those problems. Okay. Number 2 says, convert the given angle in radian measure into degrees. So we want to convert. We have pi over 15 radians, and we want to get that into degrees. So you know how you go around the circle is going to be 2 pi. And if you go halfway, that's pi. And it's also 180. So pi over 180 equals 1. And also 180 over pi equals 1. You know, you can multiply anything times 1 to get itself. So I'm going to get rid of the pi. So that means I'm going to use this 180 over pi because I want pi's to cancel. So now that the pi's will cancel, all I have to do is reduce 180 over 15. And there's a number of ways you could do that. You know, if you don't know what it is offhand, I mean, you could do 180 divided by 15. Now 15 goes into 118 once. And then you can say, well, that's a 3. Now 15 goes into 30 twice. So that means that this is 12 degrees. You know, and if you want, you could divide both by 3 or divide both by 5 and work the fraction down that way. Or you could just do a little old-fashioned long division. Okay. So that's number 2. What's number 3? Oh, number 3. It gives us a triangle like this. Okay, this is what it gives us. We've got theta over here, and we've got 16 and 30, like that. And it says, right triangle is given, evaluate the 6 trig functions. Okay, now, in order to find this third side, you'd have to use Pythagorean theorem, but guess what? You know, you can reduce this fraction down, or the fractions down. I'm noticing that both of these are even. So, you know, you could, if you just even just did that, you know, you could break it down. Well, this is 8. Half of that is 8 and half of that is 15, right? So what do we got? 8 and 15. Well, 15 is 3 times 5 and 8 is a bunch of 2s. So this is as far down as we can break it. So we got 8 and 15. So that makes the work a little bit easier to do. So I'm going to use the Pythagorean theorem. 8 squared plus 15 squared equals what squared? The hypotenuse squared. So what I'm going to do then, well, 8 squared is 64. Now, I don't know 15 offhand, but that's not too hard to do. 15 times 15. Well, let's see. We got 25, and we got 5, 6, 7, and then we got 15. And then we can add that, 7, 8, 9, 10, 11, 12. You know, and when I run out of fingers, I use my toes. That's the running joke. Okay, so plus 225 is h squared. So I'm going to go ahead and add the 64 to that. We got 9, 6, 7, 8, 289. Well, I actually recognize that. I believe that's 17. 17 times 17, just as a double check. Let's see. 7 and 7 is 49. 7, 8, 9, 10, 11. And then 17. So what do we got? Oh, 289. See, look. So 17 squared is 289. So I've got 289 equals h squared. So that's going to be 17. So now I can fill in my triangle there. That means I've got 17 here, 16, or no, I'm sorry, 8. I reduced that. So I've got 8 and 15 and 17. So that's what my triangle looks like now. And now I can do my SOHCAHTOA. The sine of theta, well, that's opposite over hypotenuse. So 15 over 17. And cosine of theta is adjacent over hypotenuse. So that's 8 over 17. Tangent of theta is opposite over adjacent. So that's going to be 15 over 8. And now the reciprocals are the easy part. Cosecant theta is 17 over 15. Secant of theta is 17 over 8. And then the cotangent of theta is 8 over 15. Probably double check my work, but there it is. Yep, good, it's all good. Just double checking. All right. Number 4. Number 4 says Use the unit circle to determine the value of cotangent of 4 pi. Okay. Then we get to complete all these cards. Okay, so cotangent of 4 pi. All right, so, okay, what do we need? We need the ordered pair and all that jazz. All right, now there's a couple things that I want to do. It says use the unit circle, but you know what? I don't really use the unit circle unless I'm just doing quadrantal angles. And if you just think about what's happening with 4 pi, let's see how you go around. How do you go around the circle? Well, it's in a positive direction because that's positive 4 pi. And you just go, you know, every time you go around the circle, that's 2 pi. So where do you land? You know, here's 2 pi, and then here's 4 pi, right? So where are you landing? You're landing right here on the positive x-axis. So it's quadrantal. It doesn't land in any quadrant. But it lands right here, and what's that ordered pair? Well, this is 1 on the x and 0 on the y. So there's your ordered pair, right? And what is that? Well, we got to figure out the cotangent of that angle. This is the same thing as the cotangent of 0. But what is the cotangent? You know, you could actually even think about this like it's a triangle. You know, if you were to draw this as a triangle, you would have 1 on the x and 0 on the y, right? And, you know, you could figure it out then that the hypotenuse, if you will, is 1 because it doesn't go up at all, right? It's just, you know, and you could use Pythagorean theorem too. You know, 1 squared plus 0 squared is what, right? Okay, so you could do it that way, and then the cotangent, right? The cotangent of this angle here is going to be what? Well, if we use this again, cotangent, you know, I should put a red box on that, right? So the cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so that means the cotangent is adjacent over opposite. So adjacent over opposite. So what's adjacent to the angle is 1, and what is opposite the angle is 0. Well, 1 over 0 is undefined. So there's that. Undefined. So, but then to answer the other questions, they want to know about the triangle. So what I like to do for that triangle, the triangle is just T, and you've got X here, you know, you've got Y there, and you've got 1 because it's the unit circle. And so the cotangent of T is going to be, you know, adjacent over opposite. So it's X over Y. Okay, where Y is not 0. So, but that's what they want there. Adjacent over opposite. Okay. Okay. All right. So, let's see, what's next? I wonder if I can pause this. I have an anxious cat. I'm just going to keep going. All right. Number 5. Number 5 says, so that was number 4. Number 5 says, find the angle of least non-negative measure, theta sub c, that is coterminal with theta equals 25 pi over 4. So what I like to do for these is rewrite this as a mixed number, 25 over 4. So 4 goes into 25 how many times? Well, 6 times 4 is 24, right? So 6 times 4 is 24, and then there's 1 left over to get to 25. So that's 6 1/4. So I'm going to go around the unit circle, if you will, or around the circle. Okay, they only want that. They don't want anything in between. Okay, so I'm going around in a positive direction, and every time I go around, it's 2 pi. So I go 2 pi, and then I go around again, and that's 4 pi, and then I go around again, and that's 6 pi, and now I got to go 1/4 more pi. So when I do, I'm going to land here, another 1/4 pi. So this in here is pi over 4. We're in quadrant 1. See, it goes around 2, 4, 6, and then there. So it goes around like that. There's pi over 4. This is your theta sub r, but it is also theta sub c. Theta sub c is the one that's between 0 and 2 pi. That's coterminal with that. So that's the angle of least non-negative measure. And there it is. That's the smallest one that's positive. So theta sub c is pi over 4. What we got? Number 6. Given a function value of an acute angle, find the other 5 trig function values. Sine of theta is 7 over 25. Okay, so now I know that the sine is opposite over hypotenuse. So I'm going to go ahead and draw my triangle. You know, this is all about triangles and which way to go around a circle, really. So here's my theta. Opposite the theta is going to be 7, and the hypotenuse is 25. So I just got to figure out the x there. Where, you know, there it is. So I'm going to use Pythagorean theorem. X squared plus 7 squared equals 25 squared. And no, I don't know what that is offhand. 25 times 25, we got 25, 10, 11, 12, and then 50. Oh, right, 625. Okay. So x squared plus 49 is 625. And now I can subtract 49. Let's see. What do we got? 6. And that's a 1. 11, 10, 9, 8, 7. And 576. 576. Oh, right. Okay, so I'm subtracting that. So x squared is 576. What is that? Well, it's got to be less than 25, right? What's 24? You know, and if you're doing your homework, you can do that. You can use calculator on your homework, but let's see, 4 times 4. And 96, 24, 48. And 17, 576. All right, so that means 24 squared is 576. So that means that x is 24. So now that I have all my sides, I can do the 6 trig functions. So here's theta, We got 24, 7, and 25. And that's just a matter of sine of theta is opposite over hypotenuse. And they gave us that. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Cosecant theta is going to be 25 over 7. Secant of theta is 25 over 24. And cotangent of theta is 24 over 7. Number 7. It says, use special right triangles to evaluate the expression. Okay, it says cosecant pi over 4. Okay. Well, if I look at this again, I know that the cosecant is going to be hypotenuse over opposite. And we want the pi over 4 triangle, which looks like this. You got to have these triangles down. And so the hypotenuse over the opposite is going to be root 2 over 1. And so this whole thing is just root 2. Okay. Number 8. Ooh, number 8. Yeah. Oh. Use identities to rewrite the following expression. So we have cosine squared of theta plus cotangent squared of theta plus sine squared of theta divided by cosecant theta. Okay. Well, before I dive in, what do we got? You know, sine squared plus cosine squared equals 1. Do you know that? You know why? What do we got? Let's say I have an angle here, and this is opposite, this is adjacent, and this is the hypotenuse. So I know that the opposite squared plus the adjacent squared is the hypotenuse squared. And if I were to divide everything by hypotenuse squared, this is what happens. Well, opposite over hypotenuse, well, that's going to be sine of theta. And since they're squared, it's squared. So sine squared theta adjacent over hypotenuse is going to be cosine, right? So cosine squared theta equals 1. So sine squared plus cosine squared equals 1. Now I'm going to go a little bit further. So I can replace this part here, cosine squared and sine squared, with a 1. Actually, I'll just go ahead and do that. 1 plus cotangent squared theta over cosecant theta. So that's where we're at now. So we got to figure out what this is, right? Now I know that cotangent is going to be, it's the reciprocal of tangent. So I need adjacent over opposite. So I'm going to need, now I know tangent is sine over cosine also. So if I want tangent, I'm going to have sine over cosine. So I'm going to divide all this by cosine. Is that going to get it? Or it's this way. Sine over cosine gets me tangent. Cosine squared, cosine squared, cosine squared. So if I do that, what do I get? I get tangent squared. Incidentally, if you divide everything by sine squared, you're going to get the third one. Okay, I was just trying to get the one for this. And the reciprocal of cosine squared is secant. See, I did the wrong one, but that's all right. Secant squared. Okay, so if I did the other one, sine squared theta plus cosine squared theta equals 1, and then divide by sine squared, which is what I wanted to do. Sine squared, sine squared, sine squared, like that. Then I'm going to get 1 plus, there it is, cotangent squared theta is the reciprocal of sine is cosecant. Okay, cosecant squared theta. So those are the other two trig functions, or Pythagorean trig identities. Okay, so that's how we get all those. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And 1 plus cotangent squared is cosecant squared. So that's how we get them. And now I can replace 1 plus cotangent squared with cosecant squared. So this is going to be cosecant squared theta over cosecant theta. And so that's just going to be cosecant theta. How's that? Okay. So that's useful. You know, maybe I'll just leave that there. Give me a page. I'm going to timestamp it. So the next one then is number 9. Determine the reference angle for theta equals negative 17 pi over 6. Okay, so the negative in front only tells us which direction we're going around the circle. Okay, and I'm going to do the same thing with the 17. 6 goes into 17. How many times? Well, 6 times 3 is 18, so that's too big. So it have to be 2, and then there's 5 left over. Right, so you can say 12, 13, 14, 15, 16, 17 is a double check. Okay, so 2 and 5/6 pi, right? So that tells me, this tells me what direction, and this tells me how far. Okay, so let me just draw this out a little bit. So I'm going to go in the negative direction now. That's clockwise. And I'm going to go 2 and 5/6 pi. So every time I go around, that's 2 pi. So there's 2 pi, right? Now I got to go 5/6 pi more. And remember, this is pi over here. So 5/6 of the way over to the pi is going to land me over here, right? In quadrant 3. This is quadrant 3. Boy, that looks a lot like pi with an extra deal, huh? All right, so quadrant 3. And if I'm going 5/6 of the way, then that means this is 1/6 in here. So this is pi over 6 in here, right? So that's my reference angle, is pi over 6. Well, what was the question? Oh, determine the reference angle. Well, that is the reference angle. It's pi over 6. All right, and they want this other stuff too. They want theta sub c. Well, if you want to find theta sub c, let me get some color here. From here to here is theta sub c. Okay. So theta sub c then is going to be pi plus pi over 6. All right. pi plus pi over 6. So that means that's 6 pi over 6 plus pi over 6, which is 7 pi over 6. So that's theta sub c. What else do they need? Okay. Quadrant 3. And then they ask for the reference angle. So quadrant 3, reference angle, and that's that. Okay. Answered all the questions for number 9. What is that? Oh no. All right, number 10. Number 10. What? Number 10 says, draw the angle in standard position and state the quadrant in which the terminal side of the angle lies, or the axis on which the terminal side of the angle lies. Now this is 11 pi over 4. Okay. So it's positive. So I know which direction to go on the circle. Means I'm going to go around this way. And 11/4, right? 4 goes into 11. Well, 3 is too big because that's 12. So it's 2, which is 8. And then there's 3 left over. Okay. So that means I'm going to go the positive direction is this way. So this gets me 2 pi. And now I got to go 3/4 pi over to here. 3/4 of the way over here. So 3/4 of the way lands me here. Right? So 3/4 to there. And that means that this in here is pi over 4. Okay. That's where we land. So we're in quadrant 2. And it looks like, oh, it chops it off a little bit, but yeah, it looks like this one here. Okay, so that's yeah, quadrant 2. Oh, it looks like that. Okay, number 11. Find the exact value of secant 23 pi over 6 without using a calculator. All right, well, 23 over 6. So 6 times 4 is 24. So that's too big. So I have to go 3, right? And then 5/6. You can double check. That's 18, 19, 20, 21, 22, 23. See? So it's 3 and 5/6. So that tells me what? Okay, so it's a positive direction. So we're going around this way. I got to go 3 pi and then 5/6 pi. So 3 pi. This is 2 pi to here, right? That's 2 pi. Then over to here is 3 pi. And now I got to go 5/6 more pi. So that's going to land me over here, 5/6. So that means this right angle in here, this is pi over 6 in here. That is your reference angle. We are in quadrant 4, right? Now, all students take calculus. And you're going to want to mark that one on your paper. This tells you what is positive in which quadrant. Okay, now in quadrant 4, cosine and its reciprocal are positive. That's what that is. So secant is the reciprocal of cosine. So that means secant is positive in quadrant 4. So let me write that down. Secant is positive in quadrant 4. And that's because of this. Okay, so that means this is equivalent to, this is the same thing as a positive from here, secant from here, pi over 6 from here. Now, what is a positive secant pi over 6? Well, I know that triangle. Pi over 6 looks like this, right? We've got 1 here, we got √3 here, we got 2 there, and what's a secant? The secant is going to be the reciprocal of cosine, so that's going to be hypotenuse over adjacent. We need hypotenuse over adjacent, and the hypotenuse is 2, and the adjacent is √3. How's that? And that's number 11. Oh. Okay, so I think we answered all the questions. Quadrant 4, positive pi over 6, secant pi over 6, and then 2 over √3. Okay, so there's a lot of questions to this problem, and there we've answered them all. All right. So at the end of the day, that's in the last box. All right. That's number 11. And we got number 12. It says, use special right triangles to evaluate cosine of 60 degrees. Now, maybe you're used to using degrees, but you know what? I'm used to using pi, because that's pretty much what we do in this class. So now if you don't like working with that, you know, you can always convert it. You know, you can go pi over 180. And then 6 over 18. 6 times 3 is 18. So this is equivalent to pi over 3. So, you know, if you prefer, you can do cosine of pi over 3. And guess what? I know that triangle. Pi over 3, this is √3, this is 2, this is 1. So the cosine, that's going to be adjacent over hypotenuse is going to be 1 over 2. Okay. Number 13. Oh, this thing keeps flashing. It says, find the missing sides of the special right triangle. Okay. So what I like to do, I always like to draw my triangles with the angle in the left corner. So this is what they give us, though. They give us this B, A, C, that this is pi over 3, and that this is 2√7. So what I'm going to do is I'm gonna draw my normal triangle. I know this is a pi over 3. So I'm going to use similar triangles here. So I know my normal pi over 3 looks like this. √3, and I've got 1 and 2. And I'm going to reorient the triangle here just so everything lines up nice. Pi over 3. So adjacent to pi over 3 is 2√7. So I want to say to myself, what times 1 gets me 2√7? And that's going to be 2√7. So if you remember, this is your constant of proportionality. You're going to multiply all these sides by 2 root 7 to get all the sides of the new triangle. Okay, so 2 times 2 root 7 is 4 root 7. Root 3 times 2 root 7 is going to be 2 root 21. Okay. I'm not sure if I know how to pause this thing. One moment. Okay, and if I label these proper, like, let's see, this one was C. This is C. And this was B. So this must be A. So there, this is AB. This is AC. And this is BC. All right, well, let's move on to number 14 then. Okay. It says, if theta is an acute angle of a right triangle, and if theta, tangent of theta is 5, then find the values of the remaining trig functions. Okay. So, oops, what's going on? Tangent of theta is 5. Then, you can think of this as like 5 over 1, right? And then you got your opposite over adjacent. So I can draw the triangle. If this is theta, then opposite is 5 and the adjacent is 1. So 1 squared plus 5 squared is the hypotenuse squared. And so that's 25, 26, right? And so the hypotenuse is 26, or square root of 26. And so now you can fill that in and do your 6 trig functions. So sine of theta, opposite over hypotenuse, is going to be 5 over root 26. Cosine of theta is adjacent over hypotenuse, so that's going to be 1 over root 26. By the way, you don't have to worry about rationalizing the denominator in this course. Okay, tangent of theta is opposite over adjacent, which they already told us. 5 over 1 is 5. Now we can just do the reciprocals. Cosecant theta is root 26 over 5. We've got secant of theta is root 26 over 1, which is root 26. Yeah, don't put over 1. It'll mark it wrong. And cotangent theta is 1 over 5. So there you have it, number 14. Number 15. Moving along. Determine the reference angle for theta equals 20 pi over 3. So, like I like to do, 3 goes into 20 how many times? Well, 6 times 3 is 18. And then there's 2 left over. So, and that's how you go around a circle. You go 2, 4, 6, and then 2/3 of the way over is over here. All right, 2/3 of the way over. So this is going to be theta sub c. And this one in here is theta sub r. And this is 2/3, so this is 1/3, or pi over 3. That is your reference angle. That's what they want. Yep, reference angle. So there's your reference angle. Pi over 3, right in here. Incidentally, theta sub r is always the one that's closest to the x-axis. So like here, this is theta sub r. Here, this is theta sub r. Here, this is theta sub r. And here, this is theta sub r, just so you know. Theta sub c is going to be the one that's between 0 and 2 pi. Okay. So like in quadrant 1, theta sub c is theta sub r. In quadrant 2, this is theta sub c from here to here. In quadrant 3, you're going to have to do this plus pi because you got to go around like this. And then if you're in quadrant 4, theta sub c is going to be 2 pi minus whatever this is, whatever theta sub r is. So that's how you can figure out what theta sub c is. And so now we're up to 16. Got a weird spot on my paper. Okay, it says given that sine of theta is 4 over root 19 and cosine of theta is root 3 over root 19, find the values of the remaining 4 trig functions. Okay, well, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So guess what? There's my triangle. I can figure that out. My hypotenuse is root 19. The opposite is 4, and the adjacent is root 3. So there's sine and cosine. So the tangent then of theta is opposite over adjacent, which is 4 over root 3. And its reciprocal, cotangent, is going to be root 3 over 4. What else do we need? Well, the reciprocal of sine is cosecant. So instead, that's just a root 19 over 4. And the reciprocal of cosine is secant. So that's going to be root 19 over 3, root 3. Okay. We're done with that. We're done with this. And we're up to 17. Okay. It says again, use the unit circle. I never use the unit circle. I'll show you how I do it. Use the unit circle to determine the value of tangent 4 pi over 3. Well, you know, if you want to answer their questions, you remember T is the angle on the unit circle. And this is X, this is Y, this is 1. So you can get all the trig functions off of that. Tangent of T, you know, is opposite over adjacent, right? Opposite over adjacent. And so, of course, you can't have 0 in the denominator. And, but I don't really do it that way. I just do, oh, and incidentally, about this thing, you know, you want to get the ordered pairs on the unit circle. You know, you just got to do this, right? Cosine of T is going to be, guess what? The cosine is adjacent over hypotenuse. So the cosine of T is X, right? And the sine of T, guess what? That's opposite over hypotenuse. So that's just Y, okay? So that means the ordered pairs are going to be, you know, XY. Here, let me write that. So that means that the ordered pair XY is going to be cosine of T, sine T. See, so all you need is the cosine and the sine, and you got your ordered pair. You just need to know what the triangle is that you're working off of. Okay. So let's say, what do we got? You know, and by the way, the quadrant you're in, you know, you can use all students take calculus, or, you know, this is a positive, positive. You got negative on the X, a positive on the Y. Here you got negative on the X and a negative on the Y. And this you have a positive on the X and a negative on the Y. And so those are the signs on your ordered pairs. It's really that simple. You know, all the pieces are really simple, but, you know, when you throw it together, it looks confusing and complicated, but it really isn't. Just look at the little pieces. They're all the little pieces are pretty straightforward. You just got to put it all together. Okay, so where was I? Oh, so this is like 1 1/3, right? 1 1/3. So where does that land us? All right, you're going to go around in a positive direction. You're going to go 1 pi, and then you're going to go 1/3 pi. That's going to land you here. So your reference angle is going to be pi over 3 in here. That's your reference angle. So you're equivalent to, now tangent, you know, if you want to do, all students take calculus, tangent is positive in quadrant 3. Also note that you're doing, you know, opposite over adjacent is going to be negative over negative, which is positive. That's why tangent is positive in quadrant 3. Now you're thinking about what happens with the little triangle in there, you know. Or you could do, you know, sine over cosine to get your tangent. Anyway, which is y over x, you know, so it's like any way you look at it, you're going to get the right answer. Okay, so we're equivalent to a positive tangent of pi over 3. Well, I know that triangle, right? Here's the pi over 3 triangle, right? That's root 3 over here. That's a 1 there and a 2 there. So the tangent of pi over 3 is root 3 over 1, which is just root 3, right? And you want to know what's the ordered pair? The ordered pair is going to be cosine sine, right? Well, what's the cosine of pi over 3? The cosine of pi over 3, that's going to be 1 over 2, right? Cosine is adjacent over hypotenuse, right? 1 over 2. The sine is going to be root 3 over 2. And then they're both negative in quadrant 3. Tangent is the only thing that's positive in quadrant 3. You know, and again, if you're thinking of the triangle, you know, you're going to have a negative over a positive, and then you're going to have a negative over a positive, and that's because the hypotenuse is always positive. Anywho, or you could just think of it as, you know, the x is negative and the y is negative in quadrant 3. So there's your ordered pair. You've got your tangent. What else are they asking for? Well, that's it. So you got, this is what they're asking for. And they're asking for the ordered pair. And then they ask for the root 3. Okay. So I like to just work it all out, and then you can fill in the answers. Okay, number 18. It says the point 1612 lies on the terminal side of an angle. Find the 6 trig functions. Okay, you know, I don't even really bother, but I can see that if I have a positive and a positive, I'm in quadrant 1. But, you know, and you could just draw that in, but I don't even bother doing that. I just draw the triangle. I've got 16 on the X, right? And I've got 12 on the Y. And guess what? These are both even numbers. As a matter of fact, they're both divisible by 4. Look, this is 4 times 4, right? And this is 4 times 3. So this gives us a similar triangle. It's a little easier to see what you're doing. You've got a 4 here and a 3 there. And oh, I recognize that. This is a 3, 4, 5 triangle. And if you need to confirm that, you can go 3 squared plus 4 squared is what squared, right? And that's going to be 9 plus 16, which is 25, right? And so H is 5, if you need to confirm that. But there, now you can just do your trig functions. Don't try multiplying all this stuff out and get bogged down in all that nonsense when you don't need to. This is just a 3, 4, 5 triangle. So the sine, we got sine is 3/5. Cosine of theta is 4/5. Tangent of theta is 3/4. And then we got our reciprocals. Cosecant is 5/3. Secant is 5/4. And cotangent is 4/3. All right. Oh, number 19. We're getting there. All right, find the exact value of tangent negative 3 pi over 4. So this just tells us the direction we're going. Okay, it doesn't have any bearing on the sign, on whether it's positive or negative. It just tells us that we're going in this direction. So 3 pi over 4. So pi is over here, and I'm going 3/4 of the way over in this direction. So 3/4 of the way lands me here, right? And then if I'm going 3/4, then that means this is pi over 4 in here. That's your reference angle, right? And so we are equivalent to, now we're in the third quadrant. Tangent is positive in quadrant 3. Okay, because all students take calculus. And so we're equivalent to a positive tangent pi over 4. That's what we're equivalent to. So, well, I know that triangle, right? Pi over 4, we got 1, 1 root 2. Probably have that memorized. And so the tangent of pi over 4 is just 1 over 1, which is 1, right? It's, opposite over adjacent is 1 over 1. Okay. Oh, I got so many papers here. Okay, number 20. It says, find the exact value of sine 2 pi over 3. And that's all they want. They don't want anything else. Okay. Sine of 2 pi over 3. All right, well, where is 2 pi over 3? I'm going this direction because it's positive 2 pi over 3. And 2/3 of the way over to pi lands me in here somewhere, right? This is 2/3, so this is 1/3. So this is pi over 3 in here. That's your reference angle. Okay, so that means we're equivalent to what? Now, all students take calculus. Sine is positive in quadrant 2. Okay, so we're equivalent to a positive sine pi over 3. Well, I know that triangle. Pi over 3, root 3, 1 and 2. So I'm going to do sine of pi over 3 is going to be opposite over hypotenuse is root 3 over 2. And that's that. Okay. Well, I guess that's all I got for you. Let me know if you got any questions. I'll try to post this as soon as I can.